Welcome to today's episode of the California GACCs Weather Terms video series. Our topic for today will be the El Niño Southern Oscillation. In this video, we will cover the differences between El Niño and La Niña and how we can use them as a tool for long-range forecasting, especially as it relates to the seasonal weather and fire potential outlook.
The El Niño Southern Oscillation, or ENSO, is one of many teleconnections, or simply recurring and persistent large-scale patterns of pressure and circulation anomalies that span vast geographical areas. These patterns typically last for several weeks to several months, and they can sometimes be prominent for several consecutive years. Teleconnection patterns reflect large-scale changes in the jet stream patterns and commonly influence temperature, rainfall, storm tracks, and jet stream location and intensity over vast areas. Specifically, ENSO is a global climate phenomenon that emerges from variation in winds and sea surface temperatures over the tropical Pacific Ocean. It has two main phases, one called El Niño and the other La Niña. The El Niño phase occurs when the ocean surface temperature along the equator off the Pacific coast of South America is at least a half a degree Celsius above average. This occurs when the trade winds weaken or reverse direction, preventing the upwelling of cold water along the equator. The La Niña phase occurs when the ocean surface temperature along the equator off the Pacific coast of South America is at least a half a degree Celsius below average. This occurs when the trade winds strengthen, allowing the upwelling of colder water along the equator. If the temperature variation from climatology is within a half a degree Celsius, ENSO conditions are described as neutral. These phases tend to stick around for periods on the order of a few months to at least a year, making them useful for longer-term seasonal forecasting. Now that you have a little background on what El Niño and La Niña are, let's dive a little bit into how they can affect global weather patterns. The warmer tropical Pacific waters during an El Niño phase can cause the Pacific jet stream to move farther south of its typical position. This shift will allow for more storms to move through the southern portion of the United States, leading to the potential for wetter and cooler than normal conditions. At the same time, the shift to the south can lead to the northern portion of the United States to be drier and warmer than normal. The cooler tropical Pacific waters during a La Niña phase can cause the Pacific jet stream to move farther north of its typical position. This shift would essentially be the reverse of what typically occurs during the El Niño phase, meaning that the southern portion of the United States would be drier and the northern portion would be wetter. It is important to recognize that these are just the typical patterns and trends during El Niño and La Niña episodes, and that actual weather patterns can remain highly variable and dynamic. As an example, the 2022 to 2023 winter was a La Niña season, but ended up being an exceptionally wet winter across California due to several atmospheric rivers moving through the region. I mentioned earlier that the phases of El Niño and La Niña tend to stick around for periods on the order of a few months to at least a year, making them useful for longer-term seasonal forecasting. Here at SouthOps, we utilize the current and forecasted ENSO phases as a tool for the seasonal weather and fire potential outlook, along with many other weather and climate factors. Of course, a lot more thought goes into the seasonal outlook than just what the ENSO phase suggests, including recent fuel moisture data, recent fire behavior, and other weather patterns. Utilizing ENSO is merely a guide to help us make informed decisions.
That's it for today's episode of California GACCs Weather Terms. We hope you now have a greater understanding of El Niño and La Niña and how they can impact long-range forecasting and ultimately our seasonal outlook forecast for fire potential. Thanks for watching, and we'll see you in the next one.